In the year 2000, deep beneath the Sierra de Nica mountains in Chihuahua, Mexico, something was about to change everything we understood about what was possible on our planet. Miners working for Industrias Peñoles were drilling deep into the earth, searching for something ordinary, silver and lead. They'd been working in this mine for decades, extracting valuable minerals from the rock, and it was a routine operation. They were about 1,000 feet below the surface, in the depths of what was already an incredibly deep mine, when their drill bit broke through a wall they weren't expecting. On the other side of that wall was a chamber that had been sealed off from the world for millennia. What happened next would become one of the most extraordinary geological discoveries in human history, and it started with an encounter so physically overwhelming that the miners could barely comprehend what was happening to them. The moment they opened that passage, the air from the chamber rushed toward them like a physical force. It wasn't just hot, it was a kind of heat that your body doesn't know how to process. The temperature was 136 degrees Fahrenheit. But more than that, the humidity was 99%. Imagine stepping into a living, breathing wall of steam and fire all at once. This wasn't the dry heat of a desert. This was moisture so thick that it coated your skin instantly, filled your lungs, made breathing feel like drowning in warm air. Scientists would later discover that in those conditions, unprotected, a human being could survive approximately 10 minutes. Maybe. Your lungs would begin to fill with fluid. The heat would start to damage your cells. Your body would lose the ability to regulate its own temperature. But the miners, despite the overwhelming sensation of stepping into an oven buried in the earth, pushed forward. They had to see what was in that chamber. They had to understand what had just been revealed. When their eyes adjusted and they looked into that space, into that hidden world beneath the mountain, they saw something that stopped them cold. The chamber was filled with crystals. Not small crystals, the kind you might find in a geode at a gift shop. Not even large crystals, the kind that make you pause and think, wow, that's impressive. These were structures so enormous, so impossibly massive, that the miners struggled to find any point of reference in the natural world. Some of the crystals were the size of telephone poles, thick cylindrical beams of pure mineral jutting from the floor and ceiling. Some were 36 feet long, some weighed 55 tons. These were the largest crystals ever discovered on Earth. Ever! In all of human history, we had never found crystals this large growing naturally anywhere. They weren't in any museum. They weren't in any geology textbook. They were here, in this sealed chamber 1,000 feet underground, untouched and unknown until this exact moment. The crystals themselves were made of selenite, a form of gypsum. In the lamplight of the miners' helmets, they glowed like frozen beams of light, like something between a crystal and a shaft of luminous energy. The colour was warm, cream and white with hints of golden tones, and as the light moved across the surfaces, the crystals seemed to shift and shimmer. It was beautiful in a way that made it seem almost unreal, like the chamber had been designed as a stage set rather than carved slowly by the patient forces of geology. And that's when the real question became urgent. How did these crystals grow so large? How long did it take? What were the conditions that made this possible? Scientists who studied the chamber after its discovery determined that these crystals had been growing for approximately 500,000 years, 500,000 years. In that vast expanse of time, the conditions in the cave had been absolutely specific, absolutely consistent. The mineral-rich water flowing through the chamber had to stay at exactly 136 degrees Fahrenheit. Cooler, and the minerals wouldn't dissolve properly. Warmer, and they wouldn't crystallize the way they needed to. The mineral concentration had to be perfect. Too much, and the crystals would grow in the wrong way. Too little, and they wouldn't grow at all. The water had to keep flowing, but not too fast, not too slowly. Every single variable had to remain in balance for 500,000 years without interruption. The probability of all these conditions aligning for such an immense period of time was so vanishingly small that it made the very existence of the cave seem less like geology and more like a miracle of nature. The miners named the chamber La Cueva de los Cristales, the Cave of Crystals. It became, almost immediately, one of the most famous geological sites in the world. Scientists travelled from everywhere to study it. Geologists, mineralogists, and researchers of every kind descended into that chamber in protective suits, trying to understand how the Earth had created something so extraordinary. They published papers. They presented findings at conferences. The Cave of Crystals was compared to other famous underground chambers, the Carlsbad Caverns in New Mexico, with their beautiful stalactites and stalagmites, the Mammoth Cave in Kentucky, one of the largest cave systems in the world, the ice caves of Iceland with their otherworldly blue glow. But nothing came close. Nothing in any other known cave could compare to the sheer scale, the sheer impossibility of what was in Nacre. These crystals didn't just exist on a larger scale, they existed in a category of their own. But here's where the story becomes even more interesting. The mine owners, when they learned about the discovery, were faced with a profound realization. They had been pumping water out of the mine for decades. They needed to remove the water to access the minerals, to keep the mining operations running smoothly. That pumping, that constant extraction of water, was what had drained the cave and exposed the crystals. If they had never started that pumping process, if they had simply left the water in the cave, the crystals would still be growing. They would still be enlarging, accumulating, becoming even more massive over the centuries to come. The conditions that had created them over 500,000 years would have continued indefinitely. In a very real sense, by mining the silver and lead, by pursuing their economic interests in the earth, the miners had accidentally interrupted a geological process that had been running since before modern humans even existed. They had stopped the growth of something extraordinary. But they had also revealed it. If you're using this to fall asleep right now, that's exactly why I make these videos. There's something deeply calming about settling into a story about the natural world, about the deep earth and the vast stretches of time that geology operates in. It puts our anxieties and our fast-paced lives into a kind of perspective. Maybe if you're enjoying this, subscribe to the Calm Archive. Let me know in the comments where you're watching from and what time it is where you are. I always read the comments, and it's genuinely fascinating to see people from all over the world, from every continent, tuning in at different times of day and night, all seeking the same thing, a moment of calm, a story to settle their minds. It means a lot to know that these videos are helping people find sleep, find peace. Anyway, let's get back to what the scientists found 1,000 feet underground. Because here's the thing that makes this discovery even more remarkable than the crystals themselves. The crystals were incredible, yes. They were the largest ever found, yes. But they weren't the most important thing in the cave. Scientists examining the crystals more closely, studying samples and analysing their composition, began to discover traces of something else, something alive. Or something that had been alive, and nobody expected what came next. And so we arrive at the question that hung in the darkness of that crystal cathedral for 500,000 years. How did this place come to be? How did the earth create something so impossible, so perfect, so utterly unlike anything the surface world had ever known? The answer begins not with the crystals themselves, but with the water that shaped them, and the ancient heat that kept them suspended in time like mosquitoes in amber. To understand the crystal cave is to understand the deep geological processes that shape our planet, processes that operate on timescales so vast that human history becomes invisible, and human lifespan becomes less than a blink of an eye. It is a story of patience written in stone, of time rendered visible as solid form. Beneath the Nacre mine, far below the surface, far deeper than any human working the silver mines would ever venture, lies something that shaped this entire story millions of years ago, a magma chamber, an intrusion of molten rock that rose from deep within the earth and never quite finished its work of creation or destruction. This magma, this remnant of the planet's violent youth, still retained enough heat after all these eons to serve as nature's furnace, warming everything above it, including the water that would become the architect of wonder. Think of it as an ember that has never gone out, glowing beneath the stone, patient and eternal, like a fire that has been tended for longer than any human civilization has existed. The cave system sits in the Sierra Madre Occidental, that great spine of mountains running through northern Mexico, born from tectonic violence when the Farallon Plate slid beneath the continent millions of years ago. Volcanoes rose, magma chambers formed, the earth remade itself in fire and pressure, and in the quiet aftermath it left behind the mineral-rich conditions that would allow something extraordinary to grow. The very violence that created mountains also created the conditions for this underground marvel. The key to everything was water. Not the surface water that we know, carrying dissolved oxygen and teeming with microorganisms, but superheated mineral water, pushed upward by the warmth of that magma chamber below, circulating through cracks and fissures in the limestone, dissolving everything it touched. This water was not pure. Far from it. It was laden with a compound called calcium sulfate, the molecular building block of gypsum, that soft, pale mineral that would eventually form selenite crystals. Imagine this water as a kind of slow-moving river, but invisible, flowing through the rock itself, carrying its precious cargo of dissolved minerals from the heat sources below upward into the chamber. For hundreds of thousands of years, this water rose and fell within the chamber, circulating in patterns that no human would ever witness, warming as it approached the magma, cooling slightly as it moved away, carrying its dissolved mineral load through the porous rock like an internal ocean with no shores. It was the most patient sculptor that ever existed, working at speed so slow that it made continental drift look like a rushing current. Every drop of water in that subterranean chamber was essentially the same as every other drop, endlessly cycling, endlessly carrying the same dissolved minerals, building the same structures year after year after year. And then something even more precise had to happen. The temperature had to be exactly right. Not just approximately correct, but precisely calibrated by the heat of the magma below, maintaining the cave at around 136 degrees Fahrenheit, 58 degrees Celsius. This was the perfect temperature, not too hot, not too cold, for calcium sulfate to remain in solution, dissolved fully in the water rather than crystallizing out all at once. Think of it like the precise temperature you need to cook an egg. A few degrees in either direction and you get something entirely different. Too hot, and everything precipitates at once. Too cold, and the minerals stick to the solution. But at exactly 136 degrees, the chemistry reaches a kind of equilibrium, a balance point where the water can hold its minerals without releasing them. Even a few degrees warmer, and the minerals would have precipitated too quickly, forming countless tiny crystals instead of these monumental structures. Imagine if every molecule decided to crystallize simultaneously. You would get sand, not sculptures. A few degrees cooler, and the process would have slowed dramatically, producing something far smaller and less remarkable. But at exactly 136 degrees, maintained by that magma chamber for 500,000 consecutive years, the conditions reached perfection. The Earth had, by chance or by some hidden mechanism we still do not fully understand, created the ideal environment for a miracle to unfold. This was a stability that the surface world could never match. Up above, in the mines where human beings worked, temperatures fluctuated with the seasons, rising and falling by dozens of degrees throughout the year. Winter brought cold, summer brought heat, spring and autumn brought transitions between the two, with rain in some seasons and drought in others. The surface is a place of constant change, constant variation. But down here, sealed away, warmed by the constant ember of the earth below, the cave maintained its temperature like a living thing maintaining a precise internal climate. The magma chamber did not cool significantly over these centuries. The insulation of the surrounding rock prevented the heat from dissipating into the atmosphere. The cave was like a thermos, like an incubator, keeping everything within at a constant, unwavering temperature. Year after year, century after century, millennium after millennium, the cave remained warm, no variations, no surprises, just the steady, unchanging heat of the deep earth. 500,000 years. Consider the span of that number for a moment. Modern humans, Homo sapiens as we understand ourselves today, have existed for only around 300,000 years. So the crystals had been growing for a time longer than our species has even existed. It is longer than the ice ages that shaped the continents, that carved the great glaciated valleys, and pushed mountains of snow across the northern hemisphere. It is longer than entire species have survived on Earth. The Neanderthals, our evolutionary cousins, had their entire existence and extinction occur within a shorter time span than it took for these crystals to develop. The entire span of recorded human history, from the first writing systems to the present day, is only a fraction of the time these crystals have been growing. And for every single one of those years, the temperature remained constant. The water remained warm, the minerals remained in solution, the stage remained set for creation, and nothing came to disturb it. Within this stable environment, the actual mechanics of crystal growth unfolded at a pace so slow that it exists almost outside of human comprehension. The largest selenite crystals in the cave, those impossible pillars measuring 40 feet or more, grew at a rate of approximately 1 millimeter every 1,000 years. To visualize this, imagine marking a single millimeter on a piece of paper. That is the distance represented. Now imagine creating that mark, and then waiting 1,000 years for the next one. Let that sink in. 1,000 years! The entire span of the medieval period, from the fall of Rome to the Renaissance, represents the growth of a line too small to see clearly without magnification. The entire era of exploration and colonization, from Columbus to the Industrial Revolution, is only 1/5 of the time it takes for these crystals to grow a centimeter. These were not quick sculptures formed in dramatic geological moments of pressure and violence. These were slow-motion monuments built atom by atom, molecule by molecule, in a darkness so complete and absolute that no human eye had ever witnessed it until the last few decades of recorded history. The patience required was almost incomprehensible, the kind of patience that only the Earth itself could manage. The process itself was almost poetic in its precision. Dissolved calcium sulfate molecules would come into contact with the growing crystal face, and there they would find a place in the lattice structure, interlocking with their neighbours in an organised geometric pattern that would eventually define the shape of the entire crystal. The molecules arranged themselves in a specific way, dictated by the angle of their chemical bonds, creating a repeating pattern that extends upward and outward in a perfectly organised manner. Then another molecule would arrive, perhaps after hours or days or weeks had passed in the darkness, and another, each one adding itself to the structure with microscopic slowness. The growing crystal face, smooth and regular, acted like a template, like a set of instructions written in chemical bonding. Any molecule that arrived found a perfectly prepared slot awaiting it, a geometric position ordained by the laws of crystallography that had been discovered only a few hundred years ago by human scientists. But the crystal had been following these laws for 500 millennia, building itself according to mathematical principles that would not be understood by human minds until the modern era. Nature had been writing equations in crystal form, and humanity was only just learning to read the language that had been written beneath the earth. The crystals were, in a sense, frozen music, rendered visible, silent songs written in the language of geometry. The result, as the explorers would eventually discover, was nothing short of miraculous. These crystals achieved a purity and a size that rival some of the finest geological specimens on Earth, and certainly surpasses them in the sheer monumentality of the structures. The largest gypsum crystal ever discovered is believed to be in this cave, a beam of selenite stretching 46 feet in length, over 3 feet in diameter, its surface smooth and lustrous despite the fact that it was formed in total darkness, never touched by sunlight in its entire existence. For perspective, that is as long as a school bus and as thick as a tree trunk. The crystal did not grow this way because it was trying to be beautiful by human standards. It grew this way because it was following the inexorable logic of chemical physics, the same logic that governs crystal growth everywhere in the universe. Yet something in that logic, something in the pure mathematics of the molecule, had created the conditions for transcendent beauty. A monument to mathematics itself, written in mineral and geometry. The selenite that composes these crystals is soft, delicate, almost fragile despite its size. You could scratch it with a fingernail or with a piece of copper. In jewellery stores, selenite is sometimes carved into ornamental pieces because of its translucent quality, the way light can pass through it and create a subtle glow from within. The crystals in the cave possess this same quality. Although no sunlight has ever reached them, they have their own internal luminescence, a pale glow that seems to come from the very structure of the crystal itself. When the explorers first descended into the cave with their lights, the beam of their flashlights struck these crystals and seemed to pass through them, creating a kind of ethereal quality, as if the light was being absorbed and transformed by the molecular structure itself. The crystals did not simply reflect light like a mirror or a piece of glass. Instead, they seemed to hold the light, to diffuse it, to transform it into something softer and more mysterious. Standing in front of a giant selenite crystal with only a flashlight for company would be like standing in front of a window made of frozen moonlight. And the cave was not unique in its formations. The Naka mine system holds multiple chambers, each one created by the same geological processes but expressing them in subtly different ways. There was the Cave of Swords, discovered much earlier, around 1910, where the selenite crystals grew in thinner, needle-like formations, like an underground forest of pale spears pointing downward. These crystals were smaller than their cousins in the giant crystal cave, typically only a few feet long, but no less intricate in their structure. These were no less magnificent than their massive cousins in the giant crystal cave, simply different, their growth constrained by slightly different water conditions or mineral concentrations. Perhaps the water temperature in that chamber was fractionally cooler, or perhaps the flow rate of the mineral-saturated water was different, allowing the crystals to develop in a different pattern. There was the Queen's Eye, a smaller chamber with crystals arranged in formations that seemed almost intentional, almost designed, as if some invisible hand had arranged them for aesthetic effect. There was the Ice Palace, where crystalline formations covered the walls like frozen waterfalls, though they were solid calcium sulfate rather than water, permanent rather than subject to the seasons. Each of these chambers told the same story, written in stone and mineral, of patient geological processes unfolding across timescales that made human history seem like an afternoon. The variety was remarkable, yet the underlying story was always the same: water, minerals, heat, and time. The geological story of this region stretched back still further, tens of millions of years, to volcanic activity that had deposited the mineral wealth that would eventually feed the growing crystals. The Sierra Madre Occidental had been shaped by ancient collisions and subductions, by the Farallon Plate sliding beneath the continental crust and bringing with it great pressure and heat. The collision of tectonic plates, a process that continues even today, had pushed magma upward and created the mineral deposits that would, millions of years later, dissolve into superheated water and slowly crystallize into the formations we see today. This tectonic violence had created the mineral deposits that Spanish conquistadors would eventually seek out centuries of years later, when the Nika mine was established as a working silver mine in the colonial era. The Spanish were looking for valuable metals, for wealth that could be shipped back across the Atlantic. They had no idea what lay deeper, far deeper, beneath their mining operations. The miners working above ground, extracting silver and other metals, were disturbing soil that had been laid down in geological time. But that mining activity was so recent in geological terms, that it was barely more than a scratch on the surface. The crystals had been growing for 500,000 years by then, and they would continue to grow for hundreds of thousands more, indifferent to the presence of human beings digging for silver, indifferent to the comings and goings of the mammals on the surface above. For modern scientists attempting to study the cave, the very conditions that had created these magnificent crystals became an obstacle and a challenge of the highest order. The heat that had nurtured their growth made the chamber nearly impossible to enter. Scientists who wished to explore the cave had to wear specialized refrigerated suits, ice-packed cooling systems built into the fabric itself, which required them to carry heavy machinery even before they could begin their work. These were not simple suits. They were essentially personal refrigeration units, with ice packs strategically placed throughout the garment, with circulation systems that pumped coolant through channels in the fabric. A single scientist entering the cave might be carrying 50 pounds of additional weight just in cooling equipment. Imagine suiting up like an astronaut preparing for a lunar mission, but you are not leaving the planet. You're simply going 1,000 feet down into the Earth. They wore breathing apparatus connected to refrigerated units, because the air itself in the deepest chambers reached temperatures of 136 degrees, and more than that, the humidity was nearly 100%. In such conditions, the air is supersaturated with water vapor. When human breath, which is warm and moist, is introduced into such an environment, the moisture in the lungs themselves can begin to condense, to collect like dew forming on a window pane on a cold morning. Scientists could not simply hold their breath to endure the heat, as might work in a very hot, dry sauna. Instead, the moisture in their respiratory system would condense, and they would begin to drown, literally drown in their own body's fluids. They would asphyxiate not from lack of air, but from the air they were breathing becoming too wet, too saturated with water for their lungs to function. The body would be working against itself, turning the very act of breathing into a danger. It is a mechanism of death that most of us will never fully understand, and perhaps that is a mercy. This meant that even suited and equipped, even wearing the most advanced protective gear that modern science could devise, scientists could work in the deepest chambers for only 20 to 30 minutes at a time. In 30 minutes, they could walk through the cave, they could make some observations, they could collect some samples perhaps, but they had to maintain constant awareness of the passage of time, because their equipment had a finite capacity. Once the ice packs began to warm, once the cooling system reached its limit, they had to exit immediately. There was no negotiation with the physical laws that governed this place. They were not merely visiting a hostile environment, the way an astronaut might visit the moon, which is merely cold and airless. They were working within the absolute limits of human physiology, on the very edge of what the human body could endure. Every expedition into the cave was a carefully planned incursion into what was almost a hostile alien world, and yet explorers returned to it again and again, because the rewards were so remarkable. The opportunity to witness and study something so unusual and so beautiful seemed to justify the risk. It was as though the cave was drawing them back, calling to them, demanding to have its secrets revealed. Before the era of human exploration and scientific study, before the first spelunker descended into the nacre mine seeking these magnificent chambers, the cave had existed in a state of perfect solitude. The water that had shaped the crystals for 500,000 years was no longer present in liquid form in the chamber when humans finally arrived. It had drained or evaporated sometime in the recent geological past, perhaps in the last few thousand years, leaving the crystals high and dry in their chamber. But before that drainage occurred, before the modern era of mining and exploration, the cave chamber had been completely filled with warm mineral water, a subterranean lake sealed away from the world, completely isolated from any other body of water. Imagine it, a lake beneath the earth, in absolute darkness, warm as bathwater, filled with the slowly dissolving and crystallizing minerals that would build these monuments. In those days, and those days stretched back through millennia and tens of millennia and hundreds of millennia, stretching back into prehistory itself, the chamber existed in a state that is almost impossible for the modern human mind to imagine. Complete darkness. Absolute darkness. The kind of darkness that exists nowhere on the surface world, where even the deepest caves are penetrated by some faint light from some distant opening, where some organisms have adapted to perceive wavelengths of light that seem invisible to our eyes. The deepest parts of the ocean have bioluminescent creatures that produce their own light. But in the sealed nacre chamber, there was no such thing. In the fully enclosed and completely sealed chamber, filled with warm mineral water, there was no light whatsoever. There was no variation in temperature. There was no weather. There were no seasons. There was no time in any meaningful sense because nothing changed, and change is what we use to measure the passage of time. Nothing grew except the crystals. Nothing lived, or so it seemed. The crystals grew in this stillness, this darkness, this warmth, this total isolation from the living world above. The selenite slowly accumulated around nucleation points, the molecular structure organizing itself according to the laws that govern all crystal growth in the universe. Symmetry and mathematics were playing themselves out at a scale so small that no eye could perceive the individual moments of growth, and yet over the immense stretch of deep time, the results became monumental. The cave was perhaps the closest thing on Earth to a place that had truly never been touched by life, or so every scientist who had ever studied it assumed. It was a sterile place, a dead place in the most literal sense, a monument to geological processes that had nothing to do with biology, a place where physics and chemistry had written their own story, unmarked by the fingerprints of evolution or adaptation or survival or death. It seemed to be the most inhospitable place for life that could possibly exist. Life, after all, requires certain things. It requires nutrients, it requires energy, it requires some mechanism of reproduction, it requires some protection from the elements. None of these things seemed to exist in the nacre crystal cave. And then, in 2008, a question was asked that nobody had thought to ask before. A scientist named Penelope Boston, a researcher affiliated with NASA, an astrobiologist whose job was to think about the possibility of life in extreme and seemingly impossible environments, descended into the nacre mine. She was not a tourist. She was not a spelunker seeking adventure. She was a researcher, someone trained to look at extreme places and ask, could life exist here? She had been studying microbial life in caves around the world, searching for organisms that could survive in darkness, in extreme heat, in conditions of radical isolation from the surface world. She had been thinking about what kinds of life might exist on other planets, in other worlds, how organisms might adapt to circumstances so harsh that they seemed incompatible with biology as we generally understand it. What if life was not as fragile and limited as we assumed? What if microorganisms could survive in places where we believed nothing could survive? And as she studied the crystals in the giant crystal cave, as she moved carefully through those impossible formations in her refrigerated suit, with her breathing apparatus hissing softly in the heat, a thought occurred to her. What if something was living inside the crystals? Not on them, not around them, but within them. What if there were tiny pores or defects or microscopic gaps in the crystal structure that contained water and that contained, impossibly, life? What if this monument to sterility and geological time actually harboured something alive? What if the oldest known crystals on Earth were not, in fact, lifeless at all? It was a simple question, but it was a question that would change everything we thought we knew about the limits of biology, and it was a question that no one had ever dared to ask. She was standing in a place that seemed designed by the laws of physics and chemistry to exclude life, and yet she was wondering, what if that assumption was wrong? What if life found a way? It was a question rooted in her experience studying life in Earth's most hostile environments. She knew that microorganisms were far more resilient than most people realized. She had encountered bacteria living in boiling hot springs, in permanently frozen soil, in absolutely pitch-black caves sealed away from sunlight for millennia. She had seen life flourish in conditions that seemed to contradict every principle of biology that scientists had taught for centuries. And now, standing in front of these massive selenite crystals, she was wondering if perhaps life had found another way, another niche, another almost impossible environment where it could establish a foothold and persist, generation after generation, for the millions of years that the crystals had been forming. The thing about crystals is that they are not perfect. They may appear perfect to the naked eye, they may seem to be solid and uniform from a distance, but under a microscope the reality is far more complex. Every crystal contains defects. There are tiny dislocations in the lattice where the molecular structure does not align perfectly. There are gaps, tiny pores, microscopic channels running through the crystal structure like invisible rivers frozen in time. These imperfections are actually quite common in crystalline structures, a consequence of the very mechanism of crystal growth. When molecules are being added one at a time to a growing crystal face, sometimes a molecule does not fit perfectly into its intended position. Sometimes there is a slight shift or misalignment. Sometimes a small pocket of water gets trapped before the next layer of molecules crystallizes on top. The result is a structure that is not purely mathematical, not purely geometrical, but instead a real object, with all the quirks and irregularities that come from growth in a natural environment. And if water could get trapped in these microscopic pores, then perhaps other things could as well. Dissolved minerals, perhaps, gases, and why not life? Why not microorganisms small enough to fit within these impossible spaces, sheltered from the world above, bathed in the warm, mineral-rich water that would allow them to metabolize and survive? It was a hypothesis that would have seemed absurd just a few years earlier. But with what we now know about extremophil bacteria, about the resilience of microbial life, about its ability to find energy from the most unlikely sources, the question suddenly seemed not just possible but plausible. And perhaps in a place like this where the temperature never changed, where the mineral composition of the water remained constant, where the conditions had remained stable for hundreds of thousands of years, perhaps there could be ancient life, incredibly ancient life, that had been growing and reproducing and evolving in these tiny pores since before modern humans even existed. This was the thought that drove Penelope Boston forward as she conducted her research in the Nacre cave. This was the possibility that made the discomfort of the cooling suit worth enduring, that made the risk of heat-induced pulmonary edema acceptable, that made the 30-minute time limit in the cave chamber seem like a reasonable price to pay. Because if she was right, if there was indeed microbial life inside these crystals, then the implications would be staggering. It would mean that life was even more adaptable, even more resilient, even more capable of finding a way to exist in seemingly impossible conditions than we had ever imagined. It would mean that the search for life on other worlds might be more promising than we had thought. It would mean that life was not a fragile phenomenon, dependent on a very specific set of conditions, but rather something far more robust and flexible. It would mean that the universe, with all its harsh and unforgiving environments, might be far more full of life than we ever dared to hope. In 2008, a scientist named Penelope Boston stood in the depths of the Naka Crystal Cave and made a decision that would reshape our understanding of life itself. Boston wasn't just a researcher. She was the director of NASA's Astrobiology Institute, an organization dedicated to finding life in the most unlikely places. And here, 1,000 feet beneath the Mexican desert, in a cave that had been sealed off from the surface world for millions of years, she believed she was standing in one of those unlikely places. The question that had lingered in the air since the 1970s, what if something was living inside these crystals, had become too compelling to ignore. It was time to find out. The investigation that began in 2008 and continued through 2009 was meticulous, deliberate, and guided by a curiosity so profound that it bordered on the spiritual. Boston and her team weren't looking for fossils. They weren't hoping to find preserved remains or traces of ancient life. No, what they suspected, what their instincts told them, was something far more extraordinary. They believed that somewhere inside these massive selenite beams, in the microscopic spaces and pockets that formed as the crystals grew, there might be life that had survived in a state of suspension for thousands of years. Life that was dormant, yes, but alive nonetheless. To find this life, the scientists had to develop a method to extract what are called fluid inclusions. These are tiny pockets of liquid, droplets of water really, that get trapped inside a crystal as it grows. Imagine, if you will, a crystal forming grain by grain, layer by layer, for millions of years. Sometimes, as new material crystallizes around older material, a bubble of liquid becomes sealed inside, preserved in a tiny capsule of selenite. These pockets are like time capsules. They hold the conditions, the chemistry, the very environment of the cave from the moment they were sealed. And possibly, they hold life. The extraction process was delicate and required a careful balance of scientific precision and protection against contamination. The scientists couldn't simply break open a crystal and examine what was inside. The moment they did that, they risked contaminating the sample with bacteria and microorganisms from the surface, from their own bodies, from the laboratory environment. So they developed protocols, sterilization protocols. They worked with extreme care, using techniques that would minimize any possibility that what they found came from outside, rather than from deep within the crystal's ancient interior. When Boston's team finally extracted the fluid from those ancient pockets and examined what was inside under a microscope, what they discovered stopped them cold. There was something there, not something dead, not fossilized remains or chemical traces of ancient life, but something living, something moving, something that, against all odds and all expectations, had survived in a state of extreme dormancy for 10,000 to 50,000 years trapped inside a crystal. They were microorganisms, bacteria and archaea, tiny single-celled organisms that had been sealed inside the crystals as the minerals crystallized around them, and there they had remained, suspended in time, in those microscopic pockets of liquid, for longer than human civilization has existed. The implications began to crystallize as clearly as the selenite around them. Life was not fragile. Life was not dependent on sunlight or movement or even oxygen. Life could wait. Life could persist in states so dormant, in conditions so hostile that it seemed impossible. But here's where the story becomes even more remarkable, because when the scientists brought these microorganisms back to the laboratory and provided them with the right conditions, not much, just a little warmth, a little moisture, and time, these ancient organisms began to wake up. They began to grow. They began to reproduce. After tens of thousands of years in absolute stasis, they remembered how to live. The membrane systems in their cells still functioned. Their genetic material was still intact. Their metabolism could still turn on, like a light switch being flipped in a dark room. Life had been waiting, and when given the chance, it remembered its purpose. This alone would have been astonishing. But Boston's team made another discovery that was equally striking. When they examined the genetic sequences of these organisms, when they compared them to the known catalogue of life on Earth, they found that approximately 90% of the microorganisms they had discovered were completely new to science. They didn't match any known species. They didn't fit neatly into any existing classification. They were unique. They were organisms that had evolved in isolation, in the darkness, in the extreme environment of the crystal cave for perhaps longer than humans have been walking upright. These were not remnants of the modern world, accidentally trapped. These were representatives of a hidden branch of life. The organisms they discovered were extremophiles, a term that means lovers of the extreme. Extremophiles are organisms that thrive, sometimes exclusively, in conditions that would be lethal to most forms of life. We know extremophiles exist in boiling hot springs, in frozen Antarctic ice, in toxic chemical lakes, in the acidic depths of mines. But discovering them in pockets of liquid trapped inside crystals 1,000 feet underground, in a state of dormancy lasting 50,000 years, represented something new. It represented an expansion of what we thought was possible for life. But perhaps the most remarkable aspect of these organisms' survival was their method of gaining energy. They didn't photosynthesize, they didn't feed on organic matter in the traditional sense. Instead, they practiced something called chemolithoautotrophy. It's a word that sounds complex, but the concept is elegant. It means they eat rock. Or more precisely, they extract energy from the minerals around them. They harvest energy from iron, from manganese, from sulfur, from other elements present in the selenite crystals and the rock formations surrounding them. They take these inorganic compounds and use biochemical processes to extract energy. They are, in essence, beings that feed on stone itself. They need no sunlight. They require no oxygen. They don't depend on the food chains and ecological networks that sustain most life on Earth. They have transcended those dependencies. They have found a way to survive in conditions of absolute isolation and deprivation. Imagine the existence they had. Those microorganisms sealed inside the crystal. No light whatsoever, no day or night cycle, no seasons, no variation in temperature beyond the slow, imperceptible changes that occur over geological time. No contact with other organisms unless they existed in the same pocket of liquid, evolving together in that microscopic world. No fresh food sources, no organic matter to consume. Just the minerals, just the crystalline walls surrounding them, just the slow chemistry of their own survival. They didn't rush. They didn't reproduce quickly. They existed in a state of metabolic dormancy so profound that 50,000 years might pass like a single breath. We can barely comprehend such a time frame, such a mode of existence. When the scientific community received news of Boston's findings, reactions were mixed. Many scientists were fascinated and excited. Here was evidence of life in conditions more extreme than anything previously documented. Here was proof that life could survive in states that challenged everything we thought we knew about the requirements for existence. But other scientists were skeptical. They raised important questions. Could these microorganisms be contamination? Could they have entered the crystals through cracks or fissures that opened after the cave was sealed? Could they have come from the researchers themselves, introduced inadvertently during the extraction and examination process? These skeptics weren't being difficult. They were being careful. Science requires skepticism. Science requires us to rule out the simple explanations before accepting the extraordinary ones. So Boston and her team spent years addressing these concerns. They developed even more rigorous sterilization protocols. They examined the fluid inclusions under magnification before opening them, looking for any signs of how contamination might have entered. They used techniques from chemistry and biology to determine the genetic lineage of the organisms they found. Slowly, methodically, they built a case. The organisms they had discovered were not contamination. They were ancient. They were native to those pockets of liquid, trapped and sealed for tens of thousands of years. As the evidence accumulated and the skepticism gradually gave way to acceptance, the implications became clearer and more profound. If life could survive 50,000 years in a dormant state, encased in crystal 1,000 feet underground, existing on nothing but minerals and trace chemicals in a tiny pocket of liquid, then where else might life exist that we had never thought to look? If such extreme conditions on Earth could harbour ancient organisms in a state of near-death stasis, then perhaps the caverns beneath the ice on Europa, one of Jupiter's moons, might not be as lifeless as we assumed. Perhaps the subsurface of Mars, where liquid water might exist beneath layers of rock and ice, could be teeming with organisms adapted to those conditions. Perhaps life, in its most fundamental forms, is far more resilient and widespread than we have ever imagined. The discovery at NACA challenged our assumptions about what it means to be alive. We tend to think of life as something active, something with movement and growth, and reproduction occurring at a rapid pace. But the microorganisms in the crystals suggested something different. They suggested that life, in its deepest essence, is about chemistry. It's about processes that extract energy and store it, that replicate information and pass it to the next generation, that adapt and evolve. These processes can occur at speeds we can barely detect. They can happen in complete darkness. They can continue for thousands of years with scarcely any change. Life is not a burning flame that requires constant fuel. Life is a coal that can glow, almost invisibly, for thousands of years, waiting for the moment when conditions might allow it to burn brightly again. And so, we return to that cave, 1,000 feet below the surface, in the heart of the Nika mountain. We return to those massive selenite crystals, those transparent beams that catch the faint light and seem to glow with an internal luminescence. We return to the extreme heat, the nearly 100% humidity, the otherworldly atmosphere that no human can survive unprotected for more than a few minutes. But now we understand that this cave is not empty. It is not dead. Within its crystals, in pockets of liquid that no human eye can see, life persists. Ancient life. Dormant life. Life that has been waiting in the darkness for longer than recorded history, asking nothing, requiring almost nothing, just existing. Just continuing. Just enduring. There's a profound peace in that image. Imagine, if you can, what it might be like to be one of those microorganisms. Imagine total darkness surrounding you. Not the darkness of night, which promises dawn, but absolute darkness. Imagine being encased in crystal, unable to move in any meaningful way. Imagine having no concept of time, no clock, no calendar, no measurement of years passing. Your existence is not marked by hours or days. It's marked only by the slow chemistry of your own survival, by the minimal processes required to maintain your structure, your essence. Imagine existing in such a state for 50,000 years. Imagine not knowing it's been 50,000 years. Imagine not knowing anything at all except the simple imperative to continue, to persist, to exist. From your microscopic perspective, a year might feel like a breath. 1,000 years might feel like an hour. A 50,000-year dormancy might feel like no time passing at all. There is no boredom because there is no awareness. There is no suffering because there is no capacity for suffering. There is only being. There is only the continuation of processes so slow, so minimal, that they might as well be geological rather than biological. You are suspended, not in animation exactly, but in a state of existence so minimal that the distinction between life and non-life begins to blur. And then, one day, though you would not experience it as a day, conditions change. You are removed from your crystal capsule. You are placed in a medium that provides warmth and moisture and nutrients. And somehow, in your microscopic being, something responds. Your metabolism, which had slowed to an imperceptible crawl, begins to accelerate. Your cell membrane, which had been in a state of suspended animation, begins to function again. The complex machinery of your biology, which had been dormant for 50,000 years, begins to turn, and you begin to grow. You begin to reproduce. You begin to live once again in the active sense. This is where we have arrived in our understanding of the crystal cave. This is the revelation that Penelope Boston and her team of scientists uncovered in 2008 and 2009 in the depths of Mexico's most extreme cave. Life is not fragile. Life is not dependent on the conditions we assume are necessary. Life is adaptable beyond measure. Life is patient beyond comprehension. Life persists in the most unexpected places, waiting for its moment, and the discovery at Nika has opened new doors. It has raised new questions. If such life exists in the caves of Mexico, what other caves might harbour similar ancient organisms? What other underground environments might contain life in dormancy? And perhaps most intriguingly, what does this tell us about the possibility of life on other worlds? These questions have begun to shape the future of astrobiology, the science of life beyond Earth. The implications ripple outward, touching everything we thought we knew about life itself. But before we explore those implications, before we understand what Nika means for the future of science and our search for life in the cosmos, we must first understand the practical challenges that scientists face when studying this cave. Because for all its wonders, for all the ancient life it contains and the secrets it holds, Nika is also a place of extraordinary danger. It is a place that pushes human physiology to the edge of survival, and accessing it Studying it and learning its secrets has required researchers to risk their own lives. In the next section, we'll explore the human side of the Nika discovery, the scientists who ventured into the depths, the physiological challenges they faced, and the remarkable feats of scientific dedication and endurance that made the study of this cave possible. The Nika discovery existed in a larger story, a much larger story, and as scientists processed what they'd found in those crystalline chambers, life, ancient and otherworldly, they began to realize that the deeper mystery wasn't really about Nika at all. It was about where life had been hiding all along. Because here's what few people understand about our planet. Most of Earth isn't like the surface where you're lying right now. Most of Earth is dark. Most of it is cold or hot in ways that would kill you instantly. Most of it is far, far below you, and most of life itself lives down there. In the 1990s, scientists began seriously investigating something called the deep biosphere. Not deep ocean, deep Earth. Not the seafloor or the underground rivers we knew about. The rock itself. The places where geology and biology intertwine so completely that it is almost impossible to tell where one ends and the other begins. As geologist and microbiologist Tullis Onstott from Princeton began studying this frontier, he started asking a question that seemed ridiculous at first. How much life actually lives underneath everything? The initial estimates made people pause. Some scientists proposed that the deep biosphere might contain something like 70% of all the bacteria and archaea on Earth. Let that sink in as you drift deeper into listening. There is more life living right now in rock layers miles beneath your feet than there is in all the oceans combined. There is more microbial biomass beneath the surface than in every forest, every reef, every living system we can see and touch. The planet we think we know, the one with visible continents and oceans and sky, is just a thin, luminous skin stretched over an ancient, thriving world of pure darkness. And the more carefully scientists looked, the more bizarre and resilient that hidden world became. In 2008, researchers exploring a South African gold mine discovered something that seemed almost impossible. 2.8 kilometers underground, nearly 2 miles down into the rock, they found a bacterium they named Desulforudis audaxviata. The name itself is poetic. Audaxviata, the bold traveller, and it earned that name. Because Desulforudis audaxviata is, as far as anyone can tell, completely alone down there. In that lightless place, isolated for millions of years, there is essentially one species, a single bacterium existing in solitude supporting its own ecosystem. Just itself. Think about that. In a cave chamber millions of years old, in a gold mine where humans had to dig to reach it, in a space where no energy from the sun has ever penetrated, there is a life form that sustains itself. And you know how? Through radioactive decay. The uranium and thorium in the rock around Desulforudis audaxviata slowly decays, emitting radiation and energy. The bacterium has evolved to harvest that energy directly from the atomic breakdown of matter. It has a metabolism so specialized that it essentially feeds on the decay of the rock itself. It converts radioactive energy into chemical energy that keeps it alive. While you sleep, while civilization hums on the surface above, this bacterium continues its ancient work, feeding on uranium atoms that have been breaking down longer than any human has existed, and will continue breaking down long after we're gone. Desulforudis audaxviata has never seen sunlight. Not once in the entire history of its existence. Not one photon from the sun has ever reached it, and it doesn't need the sun. The rock itself provides. The slow burning of uranium at the quantum level is fuel enough for an entire world. When scientists first sequenced its genome, they found something remarkable. This bacterium seems to have an unusually complete genetic toolkit. It can apparently do almost everything it needs to do on its own. Repair DNA, build proteins, process waste, reproduce. It's as if over millions of years in that isolated chamber, it has become a complete, self-sufficient system, a universe unto itself. But Desulforudis audaxviata wasn't unique. It was just one of many clues that life had conquered places no one thought it could survive. Deep in the Mariana Trench, 36,000 feet below the ocean surface, deeper than Mount Everest is tall, deeper than any light could possibly penetrate, scientists recovered sediment samples, and in those samples they found microbes, living things thriving under crushing pressure, in water so cold it borders on the impossible, miles beneath the surface of the sea. These organisms seem to thrive specifically in the strange chemistry created by hydrothermal vents. Water heated to hundreds of degrees by Earth's internal heat. Vents that create an oasis of energy in an otherwise desolate deep. These microbes had never seen the sun. They didn't need photosynthesis. They fed on chemicals, on the raw materials rising from the planet's interior. They were living proof that life didn't require sunlight, didn't require oxygen in the traditional sense, didn't require any of the things we assumed were essential. In Antarctica, sealed beneath the ice for millions of years, scientists discovered Lake Vostok and other subglacial lakes. Water. Entire lakes of water hidden beneath kilometers of ice, in permanent darkness, in cold that numbs the mind. And those lakes weren't dead. They teemed with microbial life, an entire ecosystem thriving in the least hospitable place on the surface of the continent. Life finding a way where every instinct said there was only death. The more scientists looked, the more the deep biosphere revealed itself, and each discovery pushed further into strangeness. In Romania, hidden within the Moval cave, there exists something that has been sealed off from the rest of the world for 5.5 million years. Imagine that number for a moment. 5.5 million years. Long before humans walked upright. Long before our species existed as anything more than a distant dream in evolutionary possibility. This cave was sealed, isolated, cut off from the surface world completely. And inside, a world flourished. When scientists finally breached the cave, they found 48 distinct species. Spiders with no pigmentation, pale and blind because sight was useless in a place where no light had ever penetrated. Leeches, water scorpions, crustaceans, an entire ecosystem of creatures, large and small, that had evolved completely separately from the rest of life on Earth. They had no connection to the outside world. They had never breathed surface air. Many of them didn't even have eyes anymore because evolution had rendered them pointless over millions of years. And the foundation of their entire world? Chemosynthetic bacteria. Microbes that derived energy not from sunlight but from the chemistry of the cave itself. The water chemistry, the rock, the slow processes of geological change happening in the darkness. The bacteria at the bottom of the food chain were the same kind of bacteria thriving around hydrothermal vents and deep in mines. They were the ancient currency of the Earth's true economy, the underground economy, the deep biosphere economy. When researchers studied the Moval Cave ecosystem, they realized they were looking at something that could serve as a model for life anywhere else. If life on Earth could evolve and thrive and diversify in complete isolation underground for millions of years, then the same principle might apply somewhere else. To another world, to a place with underground water, with rocks, with the slow burn of nuclear decay and the chemical reactions of geology continuing in darkness, to Mars perhaps, or Jupiter's moon Europa, where liquid water is believed to exist beneath the ice, or Saturn's moon Enceladus. This is where nature started to matter in ways that went beyond simple microbiological curiosity. NASA wasn't interested in the Naka cave just because it was spectacular. The space agency was interested because Naka represented a test case. Here was a place on Earth, a real, present-day ecosystem that embodied the extremophile frontier. It had conditions unlike anything most of Earth's surface would tolerate. Extreme heat, mineral-rich water, a sealed, ancient environment, living microbes in crystalline prisons, and if life could persist there, thriving in those conditions, then the equations changed. The possibilities expanded. Let that thought settle as you continue drifting deeper into this story. Right now, while you're breathing gently and your muscles are relaxing, there are living things miles beneath you, in the rock, in the aquifers, in the spaces between stone particles. They're patient, ancient. They've been there longer than human civilization, longer than language, longer than cities, longer than agriculture. Microbes that have never experienced wind or rain or sunlight. Organisms that don't know what a tree is, that don't know what an ocean is, even though water might flow around them in darkness. They're feeding on minerals, on radioactive decay, on chemical reactions that happen so slowly that measured in human years, they seem almost frozen in time, but on the scale of geology, on the scale of deep time, they're moving through their lives, growing, reproducing, dying, creating new generations that will continue long after this civilization is dust. Beneath your feet, beneath the basement of the deepest buildings, Beyond the reach of any well human ingenuity has ever dug, there's an entire world. A world that was discovered only recently. A world that may cover more area and contain more life than everything we can see combined. The numbers are staggering. Some estimates suggest that the deep biosphere contains more carbon, more biomass, more living matter than all the visible life on Earth combined. The total mass of bacteria and archaea living in deep subsurface environments might exceed 10 billion tons of carbon. That's a weight of life we can barely conceptualize. It's like discovering an invisible continent of biology, thriving in darkness, asking nothing of us but to leave it be. And yet, for most of human history, we didn't even know it was there. Geologists had theorized about deep life. Biologists had wondered. But it wasn't until we had the technology to drill deep enough, to sample carefully enough, to analyze with sufficient precision, that the proof became undeniable. The deep biosphere was real. It was vast. It was thriving. And it had been there all along. The realization was humbling. It suggested that life wasn't a rare, fragile thing that existed in a thin film at the surface of planets. Life was resilient. It was creative. It could exploit energy sources that seemed to violate our expectations. It could survive conditions that seemed to violate our understanding of what survival meant. Which meant one thing became increasingly clear. If we found similar conditions elsewhere, we might find life there too. The extremophils discovered in nacre, in deep mines, in subglacial lakes, in hydrothermal vents, in the very rock of the deep biosphere. They weren't anomalies. They were evidence. They were proof that life had an almost infinite capacity to adapt, to persist, to find energy and nutrients and build itself anew in places that seemed utterly barren. And as we learned more about how resilient life actually was, the universe suddenly seemed like a much less lonely place. This is where the nacre discovery became not just about one cave, but about the possibility that everywhere we looked, life might already be there. Not watching, not aware of us, but present, persistent, ancient and patient in the darkness. Scientists who study extremophils talk about something called the envelope of habitability. It's basically a set of parameters: temperature, pressure, available energy, chemical composition. For decades, we thought we knew what the envelope was. Life required liquid water, relatively moderate temperatures, sources of carbon and nitrogen. Life needed sunlight, or at least close access to it, or oxygen-rich environments. We had a picture of what a habitable place looked like, and it was pretty specific. But every new discovery from the deep biosphere expanded that envelope. Life could exist at temperatures we thought would denature proteins, in pressures that would collapse cells we understood, feeding on energy sources we never imagined organisms could use. The envelope kept growing, the boundaries kept moving outward, and with each expansion, the universe became more full of possibility. If you're still awake and enjoying this journey into the deep places of Earth, I want to ask you to consider subscribing to the Calm Archive. The algorithm that determines whether you see our videos when you can't sleep, when you need something to guide you into rest, is powered by engagement. A like really does help more people find these videos. It tells the system that this kind of slow, deep exploration matters, that there's an audience for stories that unfold like geology itself, slowly, layered, revealing the profound beneath the ordinary. So if this is helping you find your way towards sleep, thank you for letting us know by liking. And now let's get back to what lives in the dark. Because the story of nacre isn't just about Earth anymore. The cave represents something larger, a proof of concept, a working model of an ecosystem that exists under conditions that would have seemed impossible just a few decades ago. Underground water, extreme temperature variations, mineral-rich chemistry, sealed from the outside world, life persisting in forms no one expected. And NASA was asking itself a crucial question: where else in the solar system might those same conditions exist? As scientists studied the extremophils recovered from nacre, as they catalogued the bacteria and archaea living in the Mariana Trench and Antarctic lakes and deep gold mines, a possibility began to crystallize. Life on Earth had shown us that it was far more creative, far more resilient, far more capable of adaptation than we'd ever imagined. And if that was true, then our search for life elsewhere couldn't be limited to the surface. It couldn't be focused only on places like Mars, where we hope to find liquid water and mild temperatures and sunlight. Life might be hiding where we'd never thought to look, in the subsurface, in the deep places, in the darkness. and so the focus shifted. The expeditions to Nacre took on new significance. The microbes frozen in those crystals, the bacteria thriving in that alien environment, became a template, a preview of what life might look like in places we couldn't yet reach, on moons far from the sun, in the hidden oceans of distant worlds. The cave that had remained sealed for millions of years, that had preserved a record of life in extreme conditions, suddenly became important to the future of human knowledge, to our understanding of where life could be, what form it might take, how we might recognize it when we finally encountered it among the stars. But for now, as you lie here in the quiet, let that sense of depth settle into your mind. There are living worlds beneath your feet, vast networks of microbial life, thriving in darkness sustained by chemistry and geology and the slow burning of atoms. Life that doesn't know about you. That doesn't know about the sun or the sky or any of the surface world. Life that is complete and whole in itself, finding everything it needs in the deep places of the world. It's been there far longer than we have. It will be there far longer than we will be. And it's waiting, patient, silent, living out its ancient existence in the only world it's ever known. The deep biosphere, the true frontier of life on Earth, and the key to understanding whether life exists anywhere else in the cosmos. Next, we'll explore why NASA saw in Nacre something that changed everything about how we search for life among the planets. Because there's somewhere else in our solar system, somewhere with crystals, with extreme heat, with underground water locked in darkness, and scientists wonder if it might be alive. But here's where the story takes a turn that most people don't know about. Because Penelope Boston wasn't just a cave explorer, she was also a scientist with connections to one of the most ambitious institutions on Earth, NASA. And when NASA heard about what was living in that crystal cave, buried 1,000 feet underground in temperatures that would cook most organisms alive in minutes, they became very, very interested. Not just interested, funded. Because they had a theory, and Nacre's microbes were the proof they needed. You see, for decades, scientists had been looking at the night sky wondering the same question humanity has always asked. Is there life out there? And for decades, they'd been thinking about it all wrong. They'd been looking for life like us. Life that needs liquid water on the surface, a warm sun overhead, and conditions that don't stray too far from what we're comfortable with on Earth. Life under a blue sky, breathing air, thriving in moderation. That's what we thought the requirements for life were. We built our entire search around that assumption. We designed our space probes with that assumption. We pointed our telescopes at distant stars with that assumption, looking for planets that had liquid water and a stable orbit and a sun that wasn't too hot and wasn't too cold. Goldilocks planets, we called them. Just right, just like Earth. But Nacre changed everything, because the microbes living in those crystals weren't waiting for sunlight. They weren't clustered near the surface where it was more hospitable. They were thriving in absolute darkness, in heat that would incinerate most DNA, in water so saturated with minerals that by all rights nothing should have been able to use it. And yet, there they were, not just surviving, living, reproducing, growing, creating their own little world in conditions we'd previously thought were incompatible with life itself. They were the living proof that life doesn't need the sun, doesn't need comfort, doesn't need the conditions we thought were essential. Life needs something deeper, something more fundamental. And so NASA, particularly researchers interested in astrobiology, the study of life on other worlds, they started funding expeditions to Nacre. They wanted to understand what these microbes needed to survive, not what seemed comfortable, but what was actually essential. Water, minerals, chemical energy that could be harvested from the rocks themselves. Warmth, yes, but not sunlight-dependent warmth, just heat, geothermal heat. The kind of energy that doesn't come from a star but from deep within a planetary body. Heat generated by the slow decay of radioactive elements, or by tidal friction, or by the residual warmth left over from when the planet itself was young and molten. That kind of heat, that kind of energy. That's what the Nacre microbes needed. And that's what changed everything about how we think of life in space. Because once you know what actually keeps life alive, you can start asking a much more interesting question. Where else in the solar system do those conditions exist? Where else is there water and minerals and geothermal heat, waiting in the dark? The answer is almost everywhere. Almost everywhere there's a potential home for life. Let's think about Europa first, because Europa is perhaps the most likely place in our solar system where life might currently exist beyond Earth. Europa is a moon of Jupiter, a small world only about the size of Earth's moon, and it orbits in the cold darkness of the outer solar system, where temperatures on the surface drop to minus 160 degrees Celsius, minus 160. That's so cold that carbon dioxide freezes as a solid. That's so cold that most of what we think of as volatile chemicals simply crystallize and become part of the landscape. The surface of Europa is a smooth, icy plain, fractured and refrozen countless times over the course of billions of years. It looks almost artificial in its sterility, like someone poured a sheet of glass over an alien world and let it freeze solid. There are cracks, lines of darker material running across the ice, and scientists believe these cracks are evidence of water welling up from below, only to freeze again as soon as it reaches the vacuum and cold of the surface. It looks utterly dead. Utterly, completely, absolutely lifeless. But that's just the surface. Beneath the ice, and we're talking about ice that might be several miles thick, perhaps even thicker, there's an ocean. A vast, dark ocean of liquid water, kept liquid not by warmth from the sun, which is too far away to provide any meaningful heat, but by tidal heating. Jupiter's immense gravity pulls and stretches Europa constantly, like a giant hand clenching and unclenching. That friction, that constant internal massage of the moon, generates heat. Heat that warms the rocks at the bottom of that ocean. Heat that drives hydrothermal vents, hot springs in other words. The same kind of vents that powered life in Earth's deepest oceans, in places like the black smokers and the white smokers of Earth's mid-ocean ridges. The same kind of chemistry that feeds the microbes in Nika, vents that eject water superheated by the geothermal gradient, water laden with minerals and metals and chemical energy waiting to be harvested by life. Think about that for a moment. We now know that life doesn't need sunlight. It doesn't need a comfortable temperature. It doesn't need to see or feel or even be aware of the sun's existence. It needs water and minerals and heat and time. Europa has all of those, not just has them in abundance. An entire ocean, perhaps larger than all of Earth's oceans combined. Sitting beneath a shell of ice, heated from below, chemistry happening in darkness just like the chemistry happening in those crystal caves 1,000 feet underground. Reactions occurring silently in the dark water. The slow conversion of chemical energy into the stuff of life. And if microbes can thrive in nature's extreme environment, if they can find everything they need to survive in conditions so harsh that we can barely study them without sophisticated equipment and protective gear, then why couldn't life thrive in Europa's ocean? Why couldn't they have emerged there, billions of years ago, and persisted ever since, unknown and unobserved in that dark water beneath the ice? The answer is we have no reason to think it couldn't. We have every reason to think it might. More than that, we have a blueprint for how it would work, written out for us by the microbes of Nika. But Europa isn't the only world that captivates astrobiologists. There's also Enceladus, a small moon of Saturn, and Enceladus is perhaps even more tantalizing because we've actually detected evidence of what's happening beneath its surface. Unlike Europa, which we know has an ocean but can only infer its properties from gravity measurements and theory, Enceladus is actively showing us what's in its ocean. Because Enceladus has geysers, tremendous plumes of water ice and water vapor shooting up from cracks in its frozen shell at thousands of miles per hour, launching material into space where it falls back down as rain, or escapes into Saturn's rings. It's a cosmic fountain, a water feature on a cosmic scale, and the remarkable thing is that when we've analysed the material in those geysers, when we've studied the composition of what's being shot into space, we've found evidence of hydrothermal activity. We've found organics, complex carbon compounds, the building blocks of life as we understand it. We found minerals. We found evidence of chemical disequilibrium, the kind of chemistry that life uses to generate energy, the kind of redox reactions that allow microbes to convert minerals into life. Everything, in other words, that feeds the microbes in Nika. The geysers of Enceladus might as well be fountains of life's ingredients, erupting from an ocean beneath the ice. And scientists who study this stuff, they look at that data and they say, this is it. This is what we're looking for. Because Enceladus has water and minerals and heat and chemistry, all in a subsurface ocean, all potentially accessible to life if life ever got a foothold there. Which brings us to Mars. Mars is colder and stranger. and it's been dead for billions of years, at least on the surface. The surface of Mars today is a sterile desert, scoured by radiation, its thin atmosphere barely capable of keeping water in liquid form. The soil is poisoned with perchlorates, chemicals that would be toxic to most Earth life. It's a harsh place, a dead place, or so it seems. But Mars wasn't always like this. 4 billion years ago, Mars had a warmer climate. It had a thicker atmosphere. It had liquid water on the surface. Rivers flowed across the landscape. Lakes filled in low places. Possibly an entire ocean covered the northern lowlands. And life, if it emerged in that water, would have thrived. The evidence is all around us, written in stone, visible in the satellite images and the rover photographs. Mars had life's requirements. It had water. It had energy. It had an atmosphere. For hundreds of millions of years, perhaps for over 1 billion years, Mars was a place where life could exist. And then, gradually, Mars died. Its magnetic field failed. The solar wind began stripping away its atmosphere. The water evaporated or froze or seeped underground. The climate cooled. Within 1 billion years, Mars became what it is today, a cold, dry, dead world. But the evidence of what it once was remains. We can read the story in the rocks. We can see the ancient riverbeds. We can find the minerals that form in water, and we can find gypsum. Gypsum. The same mineral that fills the caves of nacre. The same mineral that surrounds the microbes that has preserved them for tens of thousands of years. We've found gypsum on Mars. Our rovers have photographed it, analysed it, documented it. It's there in the rocks, a record written in minerals of the time when Mars had liquid water. And here's the thought experiment that keeps astrobiologists awake at night, the thought that nacre makes suddenly, urgently real. If gypsum on Earth can trap microbes for 50,000 years, preserving them in a state of dormancy, their DNA essentially frozen in time, their metabolic processes slowed to almost nothing, still alive but barely. Then what about gypsum on Mars? What if, billions of years ago, when Mars still had liquid water, microbes emerged in that water? What if they thrived in Mars's oceans and lakes and rivers, just as life emerged in Earth's oceans? What if they were abundant, diverse, successful? And then, when Mars dried out, when its magnetic field failed and its atmosphere stripped away, those microbes became trapped in minerals, trapped in gypsum, dormant, waiting, preserved, waiting for 50,000 years, or 100,000, or 1,000,000. Still alive, still potentially recoverable, still detectable if we knew how to look for them and had the patience to search. The rovers we've sent to Mars, they've found that gypsum, they've photographed it, analysed it, documented it, and somewhere in those rocks, somewhere in those crystals, there might be fossil microbes. Not just chemical signatures of life, not just evidence that Mars once had conditions suitable for life, but actual preserved organisms. Evidence that life emerged on Mars just as it emerged on Earth. The smoking gun that we're not alone in the solar system, the proof that life is common, not rare, and we might be able to find it. All we have to do is understand what to look for. All we have to do is follow the lessons nacre taught us. Which brings us to an entirely new concept in astrobiology, biosignatures. A biosignature is evidence of life, but not just any evidence. It's specifically evidence that's so characteristic of biology that it couldn't plausibly have any other explanation. And for decades, scientists thought that biosignatures would be easy to spot. Oxygen in an atmosphere, for instance, or organic molecules in a rock. The assumption was that life would be obvious, that it would announce itself, that we would know it when we saw it. But nacre taught us something crucial. Life in extreme environments leaves a very different signature than life in the comfortable zones we're used to studying. The microbes in those crystals, they're not producing oxygen. They're not creating the kind of chemical signatures that photosynthetic life on Earth creates. They're doing something more subtle, more hidden. They're alive, but quietly. They're alive in a way that a rover with instruments designed to detect conventional life might completely miss. Their DNA is different. Their proteins are different. Their metabolic processes are different. They have adapted to extremes so completely that they look alien even on Earth. So NASA and other space agencies started funding research specifically designed to study the biosignatures of extremophiles. What does life look like when it's been trapped in a mineral for 50,000 years? What chemical markers does it leave? How can we teach our rovers and spacecraft to recognize life that evolved in complete darkness, in boiling water, in an environment so alien that we didn't even know it was possible before NACA? How can we build instruments sensitive enough to detect the signatures of life that doesn't broadcast itself, that doesn't announce its presence, that simply exists in the dark and goes about its ancient business of survival and reproduction? And here's where it gets really fascinating. Because one of the most direct applications of this research is already in space. The Europa Clipper, launched by NASA in 2024, is on its way to Jupiter right now. It's a spacecraft specifically designed to study Europa. It will swing by the Moon multiple times over the course of its mission, photographing the surface with unprecedented detail, measuring the thickness of the ice shell, analysing the composition of the water being ejected from those geysers. And the instruments on that spacecraft, the way they're calibrated, the data they're designed to collect, all of it was influenced by research on Earth's extreme environments. All of it was informed by what we've learned from places like NACA. The scientists who designed the Europa Clipper, they studied the extremophiles of Earth's deep biosphere. They collected samples from deep caves and deep oceans. They grew microbes in laboratories under conditions that mimicked Europa's potential chemistry. They learned what life looks like in the dark, in the heat, in the minerals and heat and pressure. And then they said, okay, if we're going to look for life on Europa, we need to be ready to recognize it in those forms. We need instruments that can detect the signatures of life that evolved in darkness, that thrives in boiling water, that doesn't need sunlight to survive. That's the connection. That's the direct line from a cave 1,000 feet underground in Mexico to a spacecraft that's currently racing toward Jupiter. It's almost poetic when you think about it. A spacecraft built on Earth, powered by technology developed over centuries, carrying instruments calibrated to look for life based on what we learned from microbes in a cave, will swing past the icy moon of an alien world and look for signs of life that evolved in an alien ocean. It will carry with it the collective knowledge of every expedition to NACA, every sample collected from those crystals, every genetic sequence analysed, every piece of evidence that life is far more resilient, far more adaptable than we ever imagined. The Europa Clipper is, in a very real sense, a spacecraft built on the foundation of what Penelope Boston discovered in that crystal cave. But there's something even bigger here, something that fundamentally changes how we think about the possibility of life in our solar system. For most of human history, we've had a very geocentric view of what life needs. We've thought life is rare. We've thought it's fragile. We thought you needed the sun. You needed a comfortable temperature. You needed a thick atmosphere and liquid water on the surface and mild conditions. You needed to be like Earth. You needed to be like us. And so we thought life was special, something that could only emerge in very particular circumstances. And so when we looked at the rest of the solar system, we saw a lot of dead places. Mars with its thin atmosphere and frozen surface. Venus with its hellish heat and sulfuric clouds. The outer moons with their ice shells and buried oceans. We saw places that couldn't possibly harbour life because they weren't like Earth. But NACA rewrote the rules. NACA showed us that we were thinking about this all wrong. NACA showed us that life only needs a few things: water, minerals, chemical energy, and time. It doesn't need sunlight. It doesn't need a comfortable temperature. It doesn't need a thick atmosphere or surface conditions that wouldn't immediately kill us. It just needs those basic things: water, minerals, energy, time. And those requirements, it turns out, are much more common than the requirements we thought were necessary. Water exists on dozens of worlds in the solar system, in oceans beneath ice, in subsurface aquifers, in comets and asteroids. Minerals exist everywhere. Chemical energy exists wherever there's heat and a chemical gradient, wherever there's a difference in oxidation states that life can exploit. And time, well, time exists in abundance. The solar system has been around for 4.5 billion years. Time is the one thing we have in plenty. And suddenly, the solar system looks very different. Suddenly, every world with subsurface water becomes a potential habitat. Every moon with geothermal heat becomes a biosphere. The icy outer system, which we once thought of as dead and frozen, becomes potentially alive, potentially teeming with life. Not with the kind of life we're used to, not with familiar plants and animals or even familiar bacteria, but with life nonetheless. Simple, single-celled life, thriving in darkness, converting chemical energy into the stuff of survival, growing and reproducing and existing in ways we've never witnessed. Just think about it. Europa, Enceladus, Titan, another moon of Saturn, which has a subsurface ocean and liquid methane lakes on its surface. Triton, orbiting Neptune, with active nitrogen geysers and an ocean beneath its frozen crust. Even Pluto, that distant dwarf planet with what might be a subsurface ocean of water ice and ammonia, heated by tidal friction from its moon Charon. Every one of these worlds, once we understood what nature was telling us about the resilience of life, became a potential home for microbial life. Billions of potential habitats, billions of possible abodes for living things we've never seen, never dreamed of, existing in conditions we would find utterly hostile. Billions of opportunities for life to have emerged independently on other worlds, creating its own biospheres, its own ecosystems, its own strange and wonderful forms. That's not metaphorical, that's not speculation, that's not science fiction. That's a direct line from a crystal cave 1,000 feet underground to the serious scientific possibility that life is common in our solar system. That's Penelope Boston bringing samples back from nature, NASA scientists studying those microbes in laboratories, running experiments, sequencing their genes, understanding what they eat and how they survive, and then space agencies redesigning their spacecraft and their missions based on that knowledge. That's the power of discovery. That's what happens when one cave, explored by one determined scientist, opens our eyes to the possibility that we live in a universe that is far more alive than we ever imagined. So pause for a moment and imagine it with me. Let your mind drift to that distant moon. Imagine Europa, a small, icy world, no bigger than Earth's moon, orbiting in the deep cold at the edge of the solar system, where Jupiter looms enormous in the black sky, radiating vast amounts of infrared light in that cold darkness. The surface of Europa is ancient ice, smooth in some places, broken and refrozen in others, with cracks running across it like the lines on a very old face. It's beautiful in its way, alien and desolate and beautiful. Nothing moves on that surface. No wind blows there because there's almost no atmosphere to blow. The solar wind strips away at the ice constantly, creating what's called an exosphere, a thin veil of molecules barely bound to the moon. It's silent, utterly silent. There's no sound in the vacuum of space, there's no movement. It's cold, so cold that temperatures barely reach minus 110 degrees Celsius. In the warmest spots where the sun shines most directly, it's utterly, completely dead on the surface. But beneath the ice, in the darkness below, there's an ocean. Think about that. An entire ocean, perhaps thousands of kilometers across, kept liquid by tidal heating, by the constant squeeze and release of Jupiter's immense gravity, by the friction that heats the rocks at the bottom. Down there, in that black water, beneath the ice, away from the sun, there might be hydrothermal vents just like the vents that powered life on Earth. Hot springs erupting from the ocean floor, carrying with them minerals and chemical energy and heat. And in that water, near those vents, life might be living. Microbes thriving in the dark, in the cold, in the pressure, in the minerals and the heat and the darkness, just like the microbes in nature, thriving in conditions we would find unbearable. Just like life, adapted to the extreme finding a way. Imagine a microbe on Europa. It has no eyes. It couldn't possibly have eyes. There's no light to see. It has no memory of sunlight. It has never evolved in sunlight. It has never needed to. It lives on chemical energy, oxidizing minerals in the hot water around a vent, using that energy to build proteins and replicate itself. It is patient. It has been living the same way for millions of years, or billions of years. Its clock ticks slowly in the cold and dark. It doesn't know anything different. It doesn't long for the surface or the light. It doesn't dream, or wonder, or question. This is its world. This is all it has ever needed. It is complete in itself, alive in a way that's utterly foreign to us, but alive nonetheless. A living thing, a creature, an organism, on a moon of Jupiter, in an ocean beneath the ice, alone perhaps, or with billions of others like it. A living thing in the dark, and somewhere on that moon, somewhere in that ocean, there might be millions of them, or billions. A whole ecosystem thriving in darkness, never to be seen by human eyes unless we send a submarine, which we might never do. An entire biosphere, a second Genesis hidden beneath the ice, waiting, patient, alive, reproducing, growing. existing in a world we can barely imagine, in conditions that would kill us in seconds, but that are to them home. That's what Nacre taught us to believe. That's what Penelope Boston's research opened our eyes to. Not that life is special or rare or precious, though it may be, but that life is opportunistic. Life emerges wherever the conditions allow, and the conditions allow in far more places than we ever imagined. In the crystal caves 1,000 feet underground, in the oceans of distant moons, in the frozen rocks of Mars, in the geysers of Enceladus. Everywhere there's water and minerals and energy, life finds a way. It finds a way because life is driven by the deepest forces of chemistry and physics, because the tendency of matter is to organize itself, to become more complex, to capture energy and use it. Because life is not an accident or an anomaly, it's a natural outcome of the universe itself. But back on Earth, back in Mexico, back at the Nacre mine, the crystal cave had one more secret. Because the story of the extremophils living in those rocks, the story of how that discovery opened our eyes to the possibility of life throughout the solar system, it wasn't finished. There was another chapter, another twist, and it had to do with what happened when the pumps were finally turned off, when the mine stopped fighting the water, when they let nature take its course and saw what would happen next. If you're feeling calm right now, if you're feeling drowsy as you listen, that's good. That's where we want you to be. And as we approach this next revelation about the crystal cave, as we get ready to hear what happened when the pump stopped, you might want to settle deeper into your pillow, get comfortable, let your eyes grow heavy. Because what comes next is the end of the story. It's the conclusion to everything we've talked about tonight, and it's perhaps the most thought-provoking part of all. In the years that followed the discovery and exploration of Nacre, something inevitable began to happen. The machines that had worked so tirelessly to keep the water out, that had made those impossible moments of human exploration possible, began to slow their rhythmic pumping. By 2015, the Nacre mine faced economic pressures. Operations reduced. The pumps that had been running continuously for years, expending enormous energy to hold back the rising water tables, were switched off. One by one they fell silent, and in that silence, nature reasserted itself. The water began to return. This was not a sudden catastrophe, not a violent inundation, but rather the slow, patient reassertion of something that had been temporarily displaced. The water that had been pushed back into the deeper chambers below, the water that had been held at bay through sheer human effort and machinery, began its inevitable climb back toward the surfaces it had occupied for 500,000 years. Imagine standing at the entrance to that mine for a moment, watching as the water levels started their slow ascent. It would have been an almost imperceptible process at first, the kind of change you would not notice day to day, but that over weeks and months became undeniable. The warm water, heated by geothermal sources deep beneath the Mexican desert, began to move upward through the limestone. Drop by drop, level by level, the chamber that had been revealed to human eyes began its return to darkness. The crystals that had stood exposed to air and human touch, that had been photographed and measured and wondered at, that had been the subject of scientific expeditions and documentaries, and the dreams of people around the world who could only see them through screens, were about to be reclaimed by the very waters that had shaped them over hundreds of thousands of years. The sound of that returning water, had anyone been there to hear it, would have been the sound of restoration, the sound of something returning home. This moment, this shift from revelation to concealment, carries with it a profound sense of closure. The world got to see Nacre's secrets for a brief window of time, perhaps 15 years or so of sustained human access to a place that had existed in perfect isolation for 500,000 years. 15 years out of 500,000. The ratio is almost incomprehensible. For those 15 years, humans walked where no human had ever walked before. We brought our lights and our cameras and our science into the darkness. We measured the crystals down to the millimeter. We collected samples of the microbes. We documented everything. And in the process, we changed something that had remained unchanged since before our species existed. Now that window was closing. The darkness was returning. The water was rising, and with it came a strange mixture of emotions that many of those who had studied the cave found themselves contemplating in the months before the final submersion. There was sadness, certainly, profound and real. a knowledge that something unique and remarkable was being hidden from human observation once more. The crystals would continue to grow, but we would not see that growth. There would be no more expeditions, there would be no more new measurements, no more discoveries of this particular place. In a sense, our time with Naka was ending. There was also, undeniably, a sense of relief. The cave was going home, in a manner of speaking. It was returning to the state it had maintained for so long, the equilibrium it had reached across eons. It was being released from the artificial conditions humans had imposed upon it. It was returning to what was natural, what was true, what was right. The rising water is not a tragedy, though it may feel like one to those of us who will never experience those vast chambers in person, who will only know Naka through photographs and descriptions and the written accounts of those who were brave enough to descend into those extreme conditions. It is instead the return of something to its natural rhythm. Before humans pumped the water out, before electricity and machinery and human ambition made that drainage possible, the cave existed in deep water. It was a flooded chamber, a sealed cavern beneath the earth where the crystals continued their patient, eternal growth. That water was warm, almost unbearably warm, and in that warmth and darkness the minerals continued their slow crystallization. The crystals did not need human observers. They did not need to be seen to be beautiful, to be real, to be worthy of existence. They had been growing in the darkness for longer than our entire species has existed on this planet, and they would continue growing in the darkness for as long as the conditions remained stable, for as long as the earth continued to heat the water, and the water continued to flow upward through the limestone, and the minerals continued to deposit themselves in patient geometric patterns. The refilling of the cave is not an ending. It is a return. It is a correction of something temporary, a restoration of something permanent. As the water rose week after week, month after month, year after year, the scientists who had sampled the cave and studied the microbes made their final measurements. They documented the changing water levels with careful precision, took photographs of the crystals as they began to disappear beneath the rising surface, watched as the formation that had been exposed to air and to eyes began its descent back into immersion. They recorded the humidity and temperature shifts, the way the air in the chamber began to change as the water level climbed. There was an urgency to this documentation, a sense that they were capturing the last glimpses of something that would soon be hidden again, perhaps for another 500,000 years, perhaps forever from the human perspective. The crystal clusters that had stood in the dry air, their surfaces already changing slightly as minerals evaporated into that heated atmosphere, were about to be immersed once more in the medium that had created them. The water would touch them again, and in touching them, the very process that had shaped them since before human history would resume. It was a closing of a door, yes, but also an opening of another door. The cave was returning to itself. This brings us to a troubling reality that some scientists began to discuss seriously as the water rose and the deadline for final access approached. The cave had been damaged, not catastrophically, not in a way that destroyed the crystals themselves, not in a way that fundamentally altered the structure of the cave system, but in small, subtle human ways. The oil from human skin, left behind on crystal surfaces by researchers who had touched the formations despite all precautions and gloves and protocols, was still there. The bacteria from human breath, released into the air of the cave during the expeditions, human respiration introducing human biology into an environment that had evolved in complete isolation from human biology, had left traces on the crystal faces. Microorganisms carried in accidentally by the expeditions, despite all the care taken to prevent contamination, had colonized certain surfaces. The crystal cave, which had been isolated from human biology for the entirety of human history, now carried the microscopic signature of human presence. This bothered some researchers deeply. Some questioned whether this was a form of contamination that could never be undone, that the cave had been permanently altered in ways that we could not fully understand or measure. Others countered that the timescale involved was almost incomprehensibly vast. The water rising again would expose those crystals to their natural environment once more. Over thousands of years, over millions of years, the natural processes of the cave would heal those marks. The warm water would wash away the oils. The native microorganisms, evolved over millions of years to thrive in this specific environment, would re-establish their dominance in that dark space. The crystals would grow again, and the marks of human contact would be buried beneath new layers of mineral deposition, layer upon layer, year upon year, century upon century, until they were invisible, undiscoverable, truly forgotten. What seemed like permanent damage from a human perspective was barely a whisper, barely a mark, barely a note in the lifetime of those structures. Yet the question remained, and it was not a trivial one. Should humans have opened this cave at all? Should we have interrupted its isolation, exposed its secrets, explored its depths? Should we have released the water and invaded the space with lights and measurement tools and the inescapable impact of human presence? Some voices in the scientific community argued persuasively that Nacre should have been left sealed forever, that whatever knowledge we gained was not worth the disruption to a unique ecosystem that had existed undisturbed for hundreds of thousands of years, that the cave was not ours to explore no matter how carefully we did so, no matter how much we tried to minimize our impact, that some places belong entirely to nature, entirely to the slow processes of the earth, and human curiosity, no matter how pure, cannot justify the intrusion. Others argued with equal conviction that the knowledge gained was extraordinary and irreplaceable, that understanding the microbes living in those impossible conditions, studying how life persists in such extreme environments, in heat and pressure that should not allow life to exist, contributes to our understanding of what life itself is capable of. That the window of access, brief as it was, taught us something profound about the nature of Earth's biosphere that we could not have learned any other way, that will shape how we search for life on other worlds, that will change how we understand the limits of biology itself. This debate, perhaps, does not have a clear answer. It sits in the uncomfortable space between curiosity and humility, between the human drive to understand and the recognition that some things may not be ours to understand. It is a question that echoes across every frontier of exploration, from the deepest oceans to the farthest reaches of space. What do we owe to the systems we discover? What responsibility comes with knowledge? What is the cost of revelation? What is lost when we illuminate the hidden places of the world? These questions will follow humanity as we continue to expand our understanding of our world and others beyond it. Nacre is simply one place where these questions became impossibly real, impossibly tangible, impossible to ignore. Yet Nacre is not alone in its otherness, in its crystalline beauty, in its status as a window into something alien and impossible on our own world. Around the world, other caves have been discovered that rival it in their strange, otherworldly character. In Spain, in the Pulpy region of Almeria, there is a cave known as the Giant Crystal Cave, discovered in 1999, which contains some of the largest selenite crystals ever found outside of Nacre itself. Those crystals, though not quite as enormous as their Mexican counterparts, still reach lengths of 11 meters or more, still rise like pillars, still create the same sense of impossible beauty in the spaces they occupy. Like Nacre, the Pulpy Cave is partially flooded. Like Nacre, access is limited and carefully controlled. The discovery of Pulpy, made after Nacre had already been explored and documented, after the world had begun to understand that such places could exist, reinforced a crucial understanding. The crystal caves we know about are likely only the smallest fraction of those that exist. For every cave we find, there may be dozens more waiting in the darkness, their crystalline formations untouched by human eyes, growing in patient silence beneath the earth. We do not know how many Nacres exist. We do not know what other secrets are hidden in the spaces beneath our feet. In Bermuda, in the underwater caves that honeycomb the limestone landscape, there are crystal formations carved by water over millions of years, glittering in ways that seem to belong to another world entirely. In Austria and other alpine regions, ice caves contain crystalline formations of frozen water that mirror the structure and beauty of their mineral counterparts, frozen in time and space, waiting in the cold darkness for eyes that may never see them. In China, in Mexico, in countries across the planet, there are caves that are barely known to science, barely explored, barely understood. Each of these places is a cathedral of geology, a temple built not by intention but by the slow, patient accumulation of minerals and eons. Each represents a frontier of Earth's beauty that remains largely unexplored, largely unknown to the humans who live on the surface above them. Each reminds us that we live on a world we do not truly know. This recognition opens outward to something even more staggering, something that should humble us and inspire us in equal measure. We live on a planet that has been explored, or so we tell ourselves. We have mapped the surface with satellites. We have photographed every square metre of land and sea from orbital altitudes. We have navigated to the poles, climbed the tallest mountains, descended to the deepest trenches of the ocean. We have circumnavigated the globe. We have sent rovers to other planets. We have done remarkable things with our science and our technology. And yet, when we speak of Earth's biosphere, when we consider where life exists and thrives on this planet, we have barely begun to explore. Scientists estimate that approximately 80% of Earth's biosphere may exist underground. 80%. In caves, in soil systems, in deep aquifers, in the spaces between rock and stone, in the places we cannot easily reach and cannot easily observe, life is teeming. And we have explored almost none of it. We know more about the surface of Mars than we do about the underground ecosystems of our own planet. We have sent probes to Europa, orbited Enceladus, and landed rovers on distant worlds. But the caves beneath our feet remain largely mysteries. The underground ocean systems of Earth remain largely unmapped. The subterranean forests of fungal networks and bacterial colonies remain largely unknown. NACA is remarkable not because it is unique, but because it is visible to us, because we got a brief window to see inside, because the universe aligned in such a way that humans were allowed to glimpse it. For every NACA, there may be 100 caves or 1,000 that we will never know existed. This humbling reality should not be depressing. Instead, it is liberating in the most profound way. It means that Earth still has secrets. It means that wonder is still possible. It means that mystery persists, even on a planet that we have circled and photographed and studied with every tool at our disposal. The universe is not running out of things to reveal to us. Our own planet is not running out of things to teach us. We have simply learned how small our knowledge is, how vast the unknown remains, how much we have yet to discover. NACA in its way is a gift. It is a reminder that there is always more, always deeper places to explore, always stranger things waiting to be discovered in the spaces we thought we knew. As we imagine the refilling of NACA, as we contemplate what happens when those final pumps shut down and silence returns to the chambers, there is a poetry worth dwelling on in the darkness. The cave is returning to a state it has maintained for longer than our entire species has existed. 500,000 years of existence, most of it in deep water, in the warm, dark embrace of the Earth. For a handful of years, humans came with their lights, and their cameras and their curiosity. We came with our science and our wonder and our need to understand. We measured and we sampled and we marveled. We documented and we photographed, and we tried to capture something that could never truly be captured by images or words. And then we left, and the water began to rise. The crystals, which had been exposed to air and to eyes, are now being slowly reclaimed by the water that created them. They are being immersed again in the warm, mineral-rich depths. They are returning home. The crystals will continue to grow. This is one of the strangest and most beautiful aspects of their return to water. The process that shaped them for 500,000 years will resume. The minerals will continue to deposit layer upon microscopic layer, building upon the structures already in place, making them larger, more elaborate, more complex. The structures will become even more impossible, even more beautiful. Somewhere in the darkness beneath the Earth, in chambers that no human eye will likely ever see, the crystals will reach sizes and configurations we cannot imagine. They will achieve a complexity and beauty that will be hidden from us forever. And that is not tragedy. That is the way of the Earth. That is the way of time itself. Things grow in darkness. Beauty accumulates in places no one sees. The universe is not diminished by being unseen. If anything, there is something sacred about growth that happens without audience. Beauty that exists for its own sake, for no purpose but its own becoming. When the final pieces of dry cave were submerged, when the water level rose past the lowest hanging crystals, past the formations that had been photographed 10,000 times, past the clusters that had been measured and documented and mapped, something shifted in the fundamental nature of the place. The cave became what it had been for 500,000 years once more, a sealed chamber, an isolated world, a place of life and growth and impossible physical conditions continuing exactly as they had before the first human footstep ever echoed in those chambers. The water would grow warmer as it rose, heated by the geothermal engines deep beneath the earth. The humidity would approach 100% once more, saturating every space, every molecule of air. The darkness would become absolute once more, the kind of darkness that has never been interrupted by any light source, the kind of darkness that is complete and perfect and infinite. And in that darkness, the microbes would continue their work, living on the edges of chemistry, persisting in ways that should not be possible, drawing energy from rock and heat and the slow dissolution of minerals. They would thrive because they always have thrived. Because evolution has honed them across millions of years to be perfectly suited for this exact environment. They need nothing but what the cave provides. They need no sun, no air, no connection to the surface world. They are complete in themselves, perfect in their isolation, infinite in their patience. Some of the crystals, it should be noted, did not return to the cave, moved by their sense of responsibility, by their understanding that they were closing a door that might never open again. Scientists carefully harvested samples before the final flooding began. Some pieces were removed with great care and preserved. They sit now in laboratories, in museums, in research institutions around the world, carefully maintained at appropriate temperature and humidity, kept safe from the ravages of time and the processes that would otherwise alter them. The microbes collected from Nacre are still alive, still being studied, still revealing secrets about the limits of life and the creative power of evolution. These specimens are a bridge between the hidden world and our own. They are proof that Nacre existed, that what we observed was real, that the impossible was indeed possible. The crystals in the labs will not grow anymore. They are no longer in contact with the warm water, the minerals, the slow processes that created them. They are frozen in time, static, unchanging, but they will not decay either. They are preserved, unchanged, a time capsule of a moment in Earth's history when humans were allowed to peek into a place they were never meant to see. They are witnesses to something that no other humans will ever witness in person again. The refilling of Nacre is a moment worth sitting with, worth contemplating as you lie in the darkness of your own space. Picture it in your mind. Picture the water level rising slowly, inexorably, following the laws of physics and geology that have governed the Earth since its formation billions of years ago. Picture the last photographs being taken, the final measurements being recorded, the last human footprints being washed away by the rising tide. Picture the moment when the water rises high enough to touch crystals that have stood in air for the first time in 500,000 years, water meeting surface in a reunion that feels like coming home. Picture the mineral-rich, warm water beginning its work of washing and coating, and slowly encasing those structures once more in its ancient embrace. Picture the temperature rising as the water fills the void, as the geothermal heat begins to warm the entire chamber once more. Picture the humidity climbing toward complete saturation, the air growing thicker, warmer, more filled with the presence of water. Picture the light from the mining operation, from the human presence, from all our intervention and intrusion, finally disappearing as the last dry surfaces go under. Picture the darkness returning. Not a new darkness, not something foreign or wrong, but the darkness that has always been the default state of this place. The darkness that was here before we arrived. The darkness that will be here after we leave. The darkness that belongs to the earth itself. And in that darkness, imagine the crystals continuing their work. Imagine the warm water slowly, slowly moving through the microscopic cracks in their surfaces, carrying minerals from distant places, depositing layers invisible to the naked eye, building upon what has already been built across 500,000 years. Imagine the slow, patient accumulation of substance and size, dimension and beauty, happening in the silence and isolation of that place. Imagine the microbes continuing their existence exactly as they have for 50,000 years, indifferent to the momentary interruption of human observation, drawing their energy from chemistry and stone, from the slow dissolution of minerals and the patient flow of heat. Imagine the cave settling back into its ancient rhythm, its patient accumulation of years and minerals and silence. Imagine the absolute stillness of that place, the completeness of its isolation, the perfect balance it has maintained for so long and will maintain for so much longer. Imagine how far beneath your feet that chamber sits, how inaccessible it has become once more, how fully it has returned to the world that belongs to it and not to us. The story of Nacre does not end with its refilling. If anything, The refilling is where the real story continues. The story we cannot see, the story happening right now in the darkness, the story that will continue for centuries and millennia and longer. The crystals are growing, the microbes are living, the cave is completing its cycle, returning to the state it has always naturally inhabited, continuing its slow work of becoming something even more remarkable than what we briefly saw. We were allowed a glimpse. We took that glimpse. We learned what we could. We brought back pieces, memories, knowledge. And now we have stepped back and the ancient processes resume. This is how it should be. This is how it must be. The earth has its secrets, and some of them are meant to remain secret. Some of them are more beautiful for being hidden. Some of them are more real for existing beyond the reach of human eyes. Naka is still there, still growing, still becoming, and that perhaps is the most wondrous thing of all. And so we return now to what we know, to the everyday world above the soil and stone. But something has changed in how we understand it, hasn't it? Something in our understanding of the world has shifted gently, like the slow turn of the earth through space. The crystal cave of Naka has given us a gift, though perhaps not the gift we expected when we first descended into that darkness. The gift is not answers. The gift is patience. Deep, profound, unrushed patience measured not in hours or days or even years, but in centuries and millennia, thousands upon thousands of years, a patience so vast that our entire civilization, our entire recorded history is barely a moment within it. Think about this as you lie here, as you settle deeper into your mattress. Those crystals began their growth more than 500,000 years ago, 500,000 years. While humanity was still learning to make fire, still discovering how to shape stone into tools, still taking the first tentative steps towards civilization, those crystals were growing so slowly that you could not perceive any change. Not in a year, not in a century, not even in 1,000 years. But the growth was there, steady, constant, unceasing. And in that slowness, there is something remarkably calming, something that speaks to us in the depths of sleep, in the quietest part of our consciousness. It tells us that there is no rush. There is never any rush. The universe moves at its own pace, and that pace is slow, beautiful, unhurried. And those microbes, those remarkable single-celled organisms suspended in the boiling water, they arrived perhaps 50,000 years ago, or longer. 50,000 years of waiting, of existing, of persisting in an environment so extreme that we thought it impossible. And they did not struggle, they did not panic, they did not ask why, they simply were. They continued. Day after day, year after year, century after century, they continued their ancient work, converting minerals, consuming energy from the earth itself, surviving on nothing but the heat and chemistry of the stone around them. There is a profound peace in that thought, isn't there? A profound and beautiful peace. These creatures did not need the sun. They did not need food or water as we understand it. They did not need other creatures or a light or company or purpose beyond the simple act of continuing to exist. And they existed. They thrived. They were alive in the truest sense of the word, in an environment where we believed nothing could live. This is what Naka teaches us, and this is what you can carry with you into your sleep tonight. We thought we knew. We believed we understood the boundaries of life, the limits of existence, the strict requirements that all living things must meet. And we were wrong. Beautifully, humbly, magnificently wrong. Beneath our feet, right now, at this very moment, in caves we have never entered and places we have never seen, life is persisting. Life is continuing. Life is expressing itself in ways we have never imagined and may never discover. And that should humble us. It should quiet the noise in our minds. It should make us recognize how vast and mysterious this world is, how little we truly know, how much remains hidden and waiting in the darkness. In a world obsessed with speed, with progress, with rapid advancement and instant gratification, there is something profoundly calming about patience measured in millennia. Our entire lives, from birth to death, are like a single heartbeat in the life of the Earth. And the Earth's life is like a single heartbeat in the life of the universe. And yet we rush. We hurry. We worry that things are not happening fast enough. But down there, in the darkness beneath Naka, in the darkness beneath all of us, patience continues. The patience of stone, the patience of water, the patience of time itself, and that patience is wiser than we could ever be. It is the wisdom of something that has learned to endure by refusing to resist, by refusing to force, by simply continuing moment after moment, age after age, without complaint and without expectation. As you lie here now, as you feel the weight of your mattress beneath you and the warmth of your blankets around you, try to remember this patience. Try to feel it settling over you like a warm blanket, heavy and safe. Your body is doing something ancient right now. Your body is resting. Your body is restoring itself. This is not a modern invention, this sleep that you're entering. This is something that has been happening in the darkness for billions of years. Animals have been sleeping since the first nervous systems evolved. Plants have been resting since the first leaves learned to close. The entire living world has been engaged in this act of restoration, this pause, this return to stillness and quiet. And you are part of that world. You're continuing something ancient. You are participating in a biological rhythm that stretches back to the very beginning of life itself. Your breathing is slowing now. Notice it. Your breath is becoming deeper, more regular, more peaceful. It is settling into a rhythm like the growth of a crystal, slow and steady and constant. Each breath in, each breath out, like water filling a cave, like minerals precipitating from solution, like time passing with a patience that asks nothing of you and expects nothing from you except that you continue. You are here, you are breathing, that is enough, that is everything. The same biological imperative that kept those microbes alive for 50,000 years in boiling darkness is keeping you alive right now. The same process that built those enormous selenite crystals grain by grain, layer by layer, is building the cells in your body as you rest. Your body knows how to restore itself. Your body knows how to sleep. Your body knows, in some deep and ancient way, that there is no urgency. There is only the quiet continuation of life, the slow work of being alive, the gentle restoration that happens in the darkness, in the silence, in the safety of your rest. Imagine now, if you will, the cave of Nika at this very moment. Right now, while you are lying here, while you're settling deeper into sleep, while you're beginning to release the concerns and tensions of the day, the cave is still there, 1,000 feet below the Chihuahuan Desert, in the darkness where no sunlight has ever reached, in the warmth that rises from the deep earth. The water is moving slowly, infinitesimally slowly, continuing its ancient work, rising and falling with the seasons, dissolving minerals and redepositing them. The crystals are still growing, so slowly that you could stand before them for your entire lifetime and perceive no change. But the growth is there, steady, patient, continuing, and the microbes are still there too if the cave is still open to them, still suspended in the boiling water, still consuming the chemical energy of the earth, still continuing their ancient existence. They do not know that humans came and visited them. They do not know that we were amazed by them. They do not know anything except the simple, profound imperative to continue, to exist, to persist, to carry forward the spark of life in this environment that seems hostile to everything we believe life should require. And yet here they are. Here they persist. And here, in the depths of sleep, you can rest, knowing that life is far more resilient, far more beautiful, far more mysterious than we could ever imagine. The weight of the earth is all around that cave, tons upon tons of rock pressing down, and yet the cave endures, the water flows, the crystals grow, the microbes live. Everything in that place exists in a kind of profound equilibrium, a balance that has been maintained for thousands of years and will continue to be maintained for thousands more. There is no struggle in that place. There is only the quiet continuation of natural processes, the endless patience of geology, the calm persistence of life. And you are part of that too, aren't you? Your body is not so different from that cave. You are mostly water. Your bones are made of minerals, calcium and phosphate and silica, the same elements that form the crystals in the darkness beneath Naka. Your cells are conducting chemistry similar to those ancient microbes, converting the food you eat into energy and heat, and the slow construction of new tissue. You are made of the same materials as the earth. You are, in a very real sense, a small piece of the earth that has become conscious, a small portion of the planet that has learned to think and feel and worry and rest. As you continue deeper into sleep now, Try to feel that connection. Try to sense the weight of the mattress beneath you as the weight of the earth. Feel the warmth of your blankets as the warmth that rises from deep beneath the ground. Feel the darkness around you as the same darkness that fills the crystal cave, a darkness that is not empty or frightening but full of life and process and ancient beauty. In that darkness, things continue, things grow, things persist, and so do you. Your body continues its work even as you rest. Your cells divide and repair themselves. Your mind processes and consolidates. Your body heals. All of this happening in the darkness and the silence and the safety of sleep. Your thoughts are beginning to dissolve now, aren't they? Like minerals dissolving in warm water, like the concerns of the day washing away like sediment settling to the bottom of a cave pool. There is nothing you need to do right now. There is nowhere you need to be. There is only this moment, this breath, this rest, this ancient, beautiful act of sleeping that humans have done since the beginning of consciousness, that animals have done since the beginning of nervous systems, that even the plants have done, in their way, since they first learned to conserve energy in the darkness. The cave is still there, deep beneath the earth, warm and dark and patient. The water is still there, moving so slowly that patience itself seems fast by comparison. The crystals are still there, growing at a rate measured in millimeters per 1,000 years. The microbes are still there if they remain, continuing their ancient dance with the chemicals of the earth. Nothing has changed in that place. Nothing ever changes in that place, and yet everything is always changing. The minerals are always rearranging themselves, the water is always moving, the life is always continuing. It is a paradox that makes perfect sense if you think about it slowly enough. If you think about it with the patience of stone, if you think about it with the peace of sleep. Your body is sinking deeper into the mattress now. You can feel it, can't you? The way your weight seems to settle, the way your muscles seem to relax without any effort on your part. It is the same process that happens in the cave, the same process that has been happening since the first sediments settled on the first ocean floor, particles falling, materials accumulating, the slow weight of time pressing down and compressing and transforming everything into something new. But you're not being compressed. You're being supported. The mattress is supporting you. The bed is supporting you. The earth beneath the bed is supporting you. Everything is holding you safely as you rest. Your breathing continues its slow, steady rhythm. Each breath in drawing fresh air into your lungs. Each breath out releasing the old. It is the same exchange that happens everywhere in nature. The same cycle of intake and release, of receiving and letting go, of holding and releasing. The trees breathe it. The ocean breathes it. The earth itself seems to breathe through the cycles of weather and seasons and geological time. And you breathe it. You are part of that cycle. You're participating in something that is vastly older than you and will continue vastly longer than you. There is comfort in that. There is peace in knowing that you are not separate from these processes, but woven into them, participating in them, continuing them. The final descent into sleep is like the descent into the cave, slower and slower, deeper and deeper. The light diminishes, the world above recedes. You become aware of the warmth and the weight and the fundamental silence of deep places. And like the cave, there is no fear in that descent. There is only the continuation of something that has always been happening. Something that humans have always done. Something that your body knows how to do without any instruction or effort from your conscious mind. Your body knows. Your body remembers in some deep cellular way the knowledge of sleep, the knowledge of rest, the knowledge that restoration comes through patience, through stillness, through releasing the need to do and simply allowing yourself to be. Right now, at this very moment, you are becoming like that water in the cave, warm, still, suspended in darkness, at rest, held by ancient stone, held by the earth itself. Your thoughts are becoming fewer and slower. Your concerns are becoming smaller and more distant. The day's events are becoming like geological layers, pressing down beneath other geological layers, becoming compressed and transformed into something that will eventually be the bedrock of your memory. And you are sinking through all of it deeper and deeper into the warmth and the weight and the profound peace of sleep. The cave is still there. The cave will always be there now, in your mind if not in the physical world. You can return to it whenever you need to remember that there is beauty in patience, that there is strength in persistence, that there is profound wisdom in the simple act of continuing, of breathing, of existing, of resting when rest is needed. The cave will wait for you. The crystals will continue their slow growth. The microbes will continue their ancient existence. The earth will continue its slow rotation and its journey through space. And you will rest. Your eyes are closed. Your body is heavy. Your mind is quiet. You're moving now into the deepest layers of sleep where dreams form and the conscious mind releases its grip on the world, where the ancient parts of your brain take over and do the work of restoration that you cannot do while awake. This is sacred work. This is healing work. This is the work that has kept humans alive since the beginning of consciousness, and your body knows how to do it. Your body remembers how to do it. Your body has been doing it every night of your life, and it will continue to do it tonight, and tomorrow night, and for all the nights that remain to you. The warmth surrounds you. The darkness surrounds you. The weight of the bed holds you safely. Your breathing continues its slow, steady pace, each breath deeper than the last, each breath slower than the one before. Your heartbeat is quiet and steady, like distant footsteps in a cave, like the slow drip of water in the darkness, like the passage of time itself measured in heartbeats and breaths, and the slow settling of sleep into your consciousness. You're safe. You are warm. You're held by something vast and ancient. You are part of something that will continue long after you're gone, and you are participating in that continuation right now, in this moment, in this rest. There is nothing more you need to do. There is nothing more you need to be except exactly what you are. A living creature, a mammal, a human being resting, participating in the ancient rhythm of sleep, joining the countless billions of creatures that rest in darkness every night. Part of the great continuity of life on this planet. The cave is still there, deep, warm, patient, still. And you are almost there now. You're almost in that place of complete rest, the place where the crystal grows, where the microbe persists, where the water moves in its own time, where nothing is rushed and everything is safe and the only sound is the slow pulse of life continuing. Continuing. Always continuing. Your eyes are heavy. Your thoughts are dissolving. The day is fading. The world is fading. There is only the warmth. There is only the darkness. There is only the slow, patient work of your body as it heals itself in sleep, as it restores itself, as it continues the ancient process that makes you alive. Let yourself sink now. Let yourself fall into the darkness like sediment falling through warm water, like minerals settling to the floor of the cave, like your body settling into the mattress, like your consciousness settling into the depths where dreams are made. There is nothing to resist. There is nothing to fear. There is only the continuation of life, the ancient rhythm, the eternal patience. Thank you for spending your evening with the Calm Archive. Thank you for allowing me to take you deep beneath the earth to that place of wonder and mystery. Thank you for resting with me. If this video helped you relax tonight, if it eased you into sleep, please subscribe so you never miss a new journey. I upload regularly, and there's always something new waiting for you. A new mystery to explore, a new place to rest, a new reason to sink into the darkness and the warmth and the profound peace of sleep. Tell me in the comments, what hidden place on earth fascinates you the most? What mystery calls to you? Where would you like me to take you next? I read every comment, and I would love to know what draws your curiosity, what soothes your mind, what helps you rest. But for now, sleep, rest. Let your body do what it knows how to do. Let the ancient wisdom of your cells guide you deeper into sleep. The cave is waiting, the crystals are growing, the microbes are persisting, the earth is turning, and you are safe, you are warm, you are held. Sleep now, rest now. The Calm Archive will be here when you wake, but until then, sink deeper into the darkness. Feel the weight of the earth beneath you. Feel the warmth surrounding you. Hear the silence that is not empty, but full of the quiet sounds of life continuing, always continuing. Close your eyes. Let them close if they are not already closed. Let your breathing slow. Let your heartbeat quiet. Let yourself become like that water in the cave, warm, still, suspended in ancient darkness, at peace, at rest, home, the cave, the darkness, the warmth, the patience. All of it is yours now. All of it is within you. All of it continues within you as you sleep. Good night. Rest well. Sleep deep.